Hello. The purpose of this video is to kind of run through the different types of chemical reactions that we learned in class, but mainly it's to update classifying the equations for single replacement and double replacement reactions, because we learned two different types of single replacement, cationic and anionic, and two different types of double replacement, precipitation and neutralization, which were not in the previous video, so this video will kind of supplement that. But I will quickly go through the other types of equations, the other types of reactions, starting with synthesis. So synthesis reactions are really easy to identify because you always have just a single product. They will always end in one product, and they will be made from simpler substances, usually they're elements. But the way you'll always recognize it is just that the one product is always on the right side of the arrow. Okay, so the two examples here, one product, one product. In both of these examples, the reactants were elements, but it could just be simpler substances. Okay, the second type of reaction, decomposition, is like the opposite of synthesis, and you can recognize decomposition by their single reactant. So again, you'll have a compound as the reactant, and then that will break down into simpler substances, again, usually elements, but not always. Here you have a single compound as the reactant. Here you have a single compound as the reactant, and usually elements, but like here, H2O is not an element, it's just a simpler substance. But again, the difference here, if the single compound is the product, then it's synthesis. You're just making one thing. Synthesis or combination, right? So you're making one product. The opposite of that is when you have a single compound as the reactant, which is decomposition or analysis, because this thing is breaking down or decomposing. Okay, so that's the first two. They're kind of similar, they're opposites, which leads us to kind of the main idea here, starting with single replacement reactions. So single replacement reactions, remember this is the sad love story of a date. You bring your friend along and your friend swoops in and steals your date. Okay, but there's two ways that this could happen, either cationic or anionic. So what you need to do is think about the element that's by itself. You need to think about what type of ion will it turn into, either positive or negative, right? Is it a cation or an anion? And that will determine who it replaces in the compound. So for example, for cationic, if we look at the example, here, aluminum is by itself. Well, we know aluminum is a metal, so when it becomes an ion, it's going to be a positive ion, or a cation. So that means when it goes to replace something in the compound, it needs to replace the positive ion, which would be copper in this case. Okay, so for cationic, it means that whatever is here is going to turn into a cation, so it needs to replace the cation in the compound. That's why it's called a cationic single replacement. Okay, when they switch, again, you go over this in the other homework assignment and everything, when they switch places, now the other positive charge becomes the element, so it will be neutral, and now aluminum has replaced copper in the compound, so you need to think about their charges and how they're going to balance. Okay, so you can watch the other videos to get more details on that, but it's cationic because in these ones, the element by itself will become a cation. Okay, because you know aluminum will develop a positive charge, so it needs to change places with the positive ion. The other type of single replacement is anionic. So this will happen when the element that's by itself will turn into an anion, or a negatively charged ion. So when it goes to switch places with something in the compound, it needs to switch places with the negative ion. Okay, so an example of this would be something like chlorine. Chlorine, when chlorine becomes an ion, it will turn into chloride, which has a negative charge. So when it goes to swoop in and steal someone's spot, it needs to switch places with the bromine, because bromide, is the one that has the negative charge. So these two would switch places. So then bromine will become the element by itself, and chloride will be in the compound with sodium. So again, you need to balance charges and think about phases and all that. Okay, so the difference between cationic and anionic is essentially what charge will this element have? Will it be positive or negative? If it's a metal, then it's going to be a cationic. The most common thing here that we'll see is a halogen if it's anionic. because that will have a negative charge. Okay, so those are the single replacement ones. Double replacement, you also have two options with double replacement. So double replacement, again, this is the double date scenario where you actually like your friend's date better and you guys switch dates. And so again, you need to be conscious of what's positive and what's negative. So the positive things need to switch places. You can't have two positive things together or two negative things together. Okay, so like in this case, the generic case, the A and B will switch places. You could also think about it in the sense that the X and Y switch places either way. But they're just going to switch partners as long as you always end up with a positive and a negative and a positive and a negative. So one result, if you remember from double replacement reactions, the only way that a double replacement reaction will happen is if you produce a solid, a liquid, or a gas, solid or water or gas. And so this is the example where you produce a solid. So remember, this one is called precipitation. And remember, a precipitate is a solid that forms in solution. So when you do your double replacement reaction and if one of your products is a solid, you check your solubility table, and one of them is a solid, that's a precipitate, right? Because you mixed two solutions and you got a solid, that's a precipitate. So the fact that you produced a solid here, precipitate, means that this is a precipitation reaction. So in order to figure out, you should first feel pretty comfortable saying, yes, that's double replacement. The only way you need to recognize that it's precipitation is that one of your products is solid. So you just check your solubility table. If you make a solid, that's precipitation. Okay. The other option for double replacement is you, again, do your double replacement. You switch these guys, these switch places, and this time you notice that one of your products is H2O, or water, right? You'll get H plus and OH minus, which you will know is H2O, which is a liquid, and this is called neutralization. So the important thing to recognize is that you make water. So essentially the difference, and we'll learn more about this later, but this is an acid and base reaction. They neutralize each other to make water. But the way you recognize the difference between precipitation and neutralization in the simplest way is that precipitation forms a solid and neutralization forms water. Okay, so you'll do the process the same way and then just look at your products and figure out, did I make water or did I make solid? Okay. The last one, the weird one that most people forget about, combustion reactions. This is when you have any reactants, really, reacting with oxygen. But the key here is that when you get your products, it also produces energy and light. So it's kind of some type of explosion or burning. The most common type that we'll see is the combustion of a hydrocarbon. So something that has carbons, hydrogens, maybe oxygen, reacting with oxygen. It will always form these two compounds, CO2 and H2O. Notice they appear in both the examples, CO2 and H2O, CO2 and H2O. Okay, so the products, if you start with something that has carbons and hydrogens, maybe oxygens, in its combustion, it will always produce CO2 and H2O. Okay, it doesn't always have to be that. It could really be any reactant, but the most common one we will see is combustion of these hydrocarbons, and you'll just get the same products. Okay. So here's kind of the breakdown of the reactions we learned. Keep in mind that most reactions really don't fit any of these, but for a lot of your assignments, they'll fit into one of these categories. So remember, cationic for single replacement means that the cations switched places. Anionic means the anions switched places. Precipitation means you formed a solid. Neutralization means you formed water. All right, so that should help you get through your homework assignment. Just for kicks, let's go through, just have a few things from the notes. Why don't we quickly just identify these single replacement reactions as either cationic or anionic. So this first one, zinc was by itself, and it switched places with copper. Since zinc and copper are cations, this is cationic. Okay. Then no reaction. Here, bromine and iodine switched places. So since bromine and iodine both have negative charges, this is anionic. Magnesium switching with hydrogen. That's positive, that's positive. Those are both cations. And then down here as well, potassium is switching places with hydrogen. So again, cationic. Okay, and then we can go through the double replacement ones. So now the option is either precipitation or neutralization. First one's no reaction, but the next one, remember we're just looking at the products here. So here we made a solid, so that would be precipitation. The next one, we formed water. Here, I'll circle this solid. Here we formed water, so this is neutralization. No reaction, and then another solid, precipitation. Okay. So that's quickly how you can tell the difference between neutralization and precipitation, and cationic versus anionic. It's usually where I get the most questions. If you're still having questions on this type of thing or just the reaction types in general, let me know, but good luck with your homework.